Okay, so today I'm supposed to be talking about the team-oriented senior research course that's going to be running next year. And so if you want to think about what we're talking about, we're going to be taking interesting ingredients and we're going to be talking about how we can put them together and create something else that's interesting. And so it's a combination of John Software and I in collaboration with Marissa Egan, who some of you may remember was a graduate from here a few years ago, who's now the lead chemist out at Victory Brewing. And we've talked about creating this course that we're going to call From Grain to Tap, the Science of Brewing. And there's an awful lot of interest in this, from all sorts of areas. We've talked about a bunch of different things that could be done as a part of this course, and this is not meant to be an all-inclusive list. But some of the things that we talked about is there could be stuff in the area of biochemistry, analytical chemistry, as well as organic chemistry, comparing different methods for measuring the amount of alcohol or ethanol that's in the beer. And this is something that you say, oh, this must be really simple. It's done all the time, but it turns out it's a little bit more complicated than you might think. We're going to talk about, or we're thinking about developing methods for the analysis of fermentable sugars. When people actually brew the beer, they're actually extracting the sugars out of the malt, and this is, where these come from for the yeast to work on. And understanding the range of sugars that are there is something that would then contribute to what's going on in the final product. There are things that sometimes occur in beer, like diacetyl is one, that contribute off-flavor to it. And there's a variety of methods that people analyze for these things. Some are easier than others. Oxidation of beer is generally a problem, and so they sometimes give rise to off-flavor components. One of the things about this diacetyl is that the yeast actually produce it during the course of fermentation, but then they also then eat this up, once they get through it. And so you have to actually produce and let the beer ferment for a particular length of time to get through that secondary process. And so the kinetics of this are not completely understood. And so we've talked about some studies of that. When you add hops, the different alpha and beta hop acids that are there give rise to, different things, and they change during the brewing process. You could do simple things like measuring, quantities like the beer bitterness. There are standard methods that are generally spectrophotometric-based methods, but there's been some work lately on trying to develop more instrumentation-based methods, like for LCMS, as well as just regular straight HPLC. And then, the effects of temperature and pH on the brewing process, how you actually can get through and change those things to, make different interesting types of beer. Now, obviously, beer is a cool chemical mixture, but it's also produced in a biological way, and so certainly there are biology-related things, amylase activity, looking at the yeast themselves and what their metabolism is under different conditions, what yeast is actually there, whether there's a mixture of yeasts or whether it's pure strains of yeast, and how these affect, what the results are. When you're trying to get rid of the yeast at the end and how that's affected. There's all sorts of things here that, we've talked about, could give rise to some really, really interesting projects, during this. And so what we anticipate is going to happen is that, anybody who's in this course is going to learn the basics of the brewing process, and you don't learn things except really by doing them. And so what we're going to do is we're going to make some, we think, micro batches of beer. We've talked about maybe even making some nano batches of beer. And so the idea is that, we are going to have small teams working on this. The teams will get different research projects, whatever they're interested in, learn the instrumentation that they need to use in order to do those projects. And then we would like to see that, different people, hopefully we'll have more than one person in the course, we'd like to see that different people maybe take ownership of certain measurements that they could make in different places, and then be the ones, the go-to people for those kinds of measurements as we go through different studies. We expect that there's going to be a whole variety of different analytical techniques. Being an analytical chemist, of course, I think about those things first. But we're going to, try to, use a whole lot of different analytical techniques. There are lots of techniques that are the standard methods that brewing chemists use to study these things. And one of the things that I find interesting is that over time, like recently, they've been developing more instrumentation-based methods, again, to replace some of the older, really simplified methods that have been in use. And just like regular senior research, it's going to be 9 credits, 3 credits a term during the fall, winter, and the spring. One of the things that's different is we will have scheduled blocks of time. We'll be meeting in a classroom. I don't know whether it'll be 406 in Disque, but the idea is we'll be having scheduled blocks of time. But then there will be some other time, when lab work is going to be done. There are going to be both individual as well as team deliverables. Everybody needs to understand that word deliverable. One of the things when I talk to my colleagues in industry is they accuse us in academia of not knowing what that word means. And so, we're going to have individuals presenting, recent research articles, whether it be on the brewing process or an analysis of the brewing process. There is going to be team deliverables. All of these kinds of things. We have to design what the project is and then figure out how to basically get it from the beginning all the way to the end. And then just like we were doing with the regular senior research project, we expected in the spring of next year that people would be involved with the 1 credit course, for writing the final report, for the end of the term. I believe that goes to the end. So that's what the idea is for next year's research course.
Are faculty allowed to register?
Do we get to drink the stuff at the end?
Yes.
The drinkable?
What's that?
Forget the deliverables, is it drinkable?
Deliverables. One would hope so.
But the AA is good because no copper, no beer. No, really,
Yes,
no copper, no beer.
I understand.
Do we have cobalt lamp as well?
We absolutely do.
Good.
The
Vanadium?
We don't have vanadium at the moment, but we
Maybe
have
I'll look at that over some.
the wrong amount of calcium or magnesium. No good beer. There's all sorts of little things that you don't realize until you look into it. It's a little bit more complicated than throwing things in a pot and cooking them and then letting them sit.
Kevin, is that what? The 480, not the 493?
Because this is the course.
Oh, this is the
So this is the alternative course. So at the moment we don't have. This will be the second year that it runs. So we'll see how it goes.
You also want to recruit students for 493 also, right?
What's that?
You also
It's
want
in
to-
place of
In place of 493.
Oh,
How many were in 480? The corresponding thing was last year.
4.
4.
I suppose we could think about just creating a 493 section for
We could do that.
which
Like for mechanistically, we could do that.
that actually would have eliminated some of the logistical issues that we dealt with this year because you can't set up a TBA 480.
Okay, so that's a good thing for logistical purposes. So for those undergrads in the audience, we'll get back to you with the details of how to sign up for it.